Okay, the problem earlier was the integral of the square root of 4 minus x squared, where we use sine. This time our integral is the square root of 4 plus x squared. So I'm going to use here tangent, and this is what we need to know, okay? So that is your form a squared plus u squared. So a is 2 and u is x. It's a linear function x, okay? So because this is plus, then it implies that that must be the hypotenuse of the right triangle. That must be the square root of 4 plus x squared. So I can say this could be x and this could be 2, or this could be x and this could be 2. You can interchange them. Using x over here will give me, if this is now my theta, tangent theta is equal to x over 2. But if I drew my triangle like so, this is the same, 4 plus x squared, but you put here x instead of 2, and you put 2 here, then I will be using cotangent. This is my theta, adjacent over hypotenuse. Now, you can use either way, and both of them will give you the same answer, but let's just stick to tangent, okay? This means we can rewrite x as 2 tangent theta. And our goal is to rewrite this original integral without the square root sign. So how do we do that? Here we go. The square root of 4 plus x squared will now be written as 4 plus, in place of x, I will put 2 tangent theta. Squaring that will give me 4 plus 4 tangent squared theta, which will give me 4, 1 plus tangent squared theta. And then we know from our trigonometric identities that 1 plus tangent squared theta is equal to secant squared theta. And so there you go. That simplifies to 2 secant theta. Okay, so now we have found a replacement for the integral of 4 plus x squared. We now need to find a replacement for dx, and that will come from this. What is our x? X is 2 tangent theta, so all we will have to do is find the dx with respect to theta, and that's gonna be 2 secant squared theta, which we can write as dx is 2 secant squared theta d theta. So putting the two together, here we go now. The integral of the square root of 4 plus x squared dx becomes now, in terms of trigonometric function, this square root is simply 2 secant theta, whereas this dx becomes 2 secant squared theta d theta. Aha, we can simplify this and pull out the 4. And so we get secant cubed theta d theta. To evaluate this particular integral, we will use integration by parts. Now, how do we know we're gonna use integration by parts here? If you look at the original integral here after replacing them in terms of theta, we notice that secant squared theta has an integral, which is tangent, right? We can get the derivative of this, okay? Secant tangent. So here we go. We will let u be equal to secant theta. And what's the derivative of secant? Secant theta, tangent theta. Let's put the d theta here. What about the dB part? Remember, the dB must be some expression where you can find the integral very easily, okay? So we will have secant squared theta, d theta. And so getting the integral of the right-hand side will produce the v, which is tangent theta. So, using u dv substitution, we now have the integral of secant cube. Now, notice that I did not write the 4, okay? I can put back the 4 after we finish integrating secant cube. And so here we go. Remember the form for integration by parts. U dv is equal to uv minus v du. So, what is our u here? Our u is secant theta, right there. Our v is tangent theta, minus our v is tangent theta, and our du is secant theta tangent theta. Simplifying our integral part, we notice that it is equal to tangent squared theta secant theta. Aha! We can replace tangent squared by its equivalent in trigonometric identity. That's equal to secant squared theta minus 1 times secant theta. And so we get secant cubed theta plus secant theta d theta, which we can rewrite as negative secant cubed theta minus d theta minus secant theta d theta. That will now become negative times negative is positive, right? So, I'm sorry, this should be negative still because I put them in parentheses. So, if you recall, our original problem was, let me put it back here, okay? Secant cubed theta d theta is equal to secant theta tangent theta minus secant cubed theta plus secant theta. What we can do is combine this secant cubed theta over here with this. And so we get 2 secant cubed theta d theta is equal to secant theta tangent theta plus the integral of secant theta, and the integral of secant theta is ln of secant theta plus tangent theta d theta. Plus c. So the integral of secant cubed theta d theta is equal to 1/2 of secant theta tangent theta plus 1/2 of ln of secant theta plus tangent theta plus c. Okay, let me continue from here. So our last result was 2 times the integral of secant cubed theta d theta is equal to 1/2. We divided both sides by 1/2, so that becomes 1. So 1/2 secant theta tangent theta plus 1/2 ln of secant theta plus tangent theta. Our goal was to find the integral of the square root of 4 plus x squared dx, okay? So we're now going to rewrite this in terms of x. But we must not forget that earlier we removed that 4, right? We simply focus on secant cube. So we're now going to put back that 4. Here we go. So 4 secant cube theta d theta. This now will become 4 times 1/2 secant theta tangent theta plus 1/2 ln of secant theta plus tangent theta plus c, which simplifies to 2 secant theta tangent theta plus 2 ln of secant theta plus tangent theta plus c. Okay, now let's rewrite it in terms of x. So if you recall, our triangle was this, right? So we're using this form. So we're gonna use this triangle to rewrite our final answer. So let me copy our final answer. The integral of 4 plus x squared dx, okay, became 4 times the integral of secant cube d theta, which became 2 times secant theta tangent theta plus 2 times ln of secant theta plus tangent theta plus c. So, using this particular triangle, what is secant? Secant is the reciprocal of cosine, so it is the square root of 4 plus x squared over 2. Tangent is opposite over adjacent, x over 2. Ln of the square root of 4 plus x squared over 2 plus x over 2 plus c. So simplifying our answer, we should get these two will cancel. 1/2 x times the square root of 4 plus x squared. Now, I'm going to use here properties of logarithms. We recall that, here we go, let me review that a bit. Ln of a plus ln of b can be written as ln of ab, right? And then ln of a minus ln of b can be written as ln of a over b. So, I'm gonna write this as, here we go now, ln of, since they have the same denominator, we can write this as x plus the square root of 4 plus x squared over 2. And so, using this form, we can now rewrite this as 1/2 x square root of 4 plus x squared plus 2 times ln of x plus the square root of 4 plus x squared plus ln of 2. I'm sorry, minus ln of 2, because this is division, right? So minus ln of 2 plus c, which can be written finally as 1/2 x times the square root of 4 plus x squared plus 2 times ln of the absolute value of x plus the square root of 4 plus x squared. And so we end up here with c minus ln of 2 plus c. Well, ln of 2 is just a constant. The whole thing becomes a constant. And so we can simply rewrite our final answer as 1/2 x times the square root of 4 plus x squared plus 2 ln of the absolute value of x, 4 plus x squared plus c. So this whole thing simply becomes a c, okay? And finally, another way of writing this is 1/2 x square root of 4 plus x squared. We can pull out the 2 and make it an exponent, so we don't need to use that absolute value, plus c.